This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software. Digitalocean is the easiest cloud platform to deploy, manage, and scale applications of any size, removing infrastructure friction and providing predictability so developers and their teams can deploy faster and focus on building software that customers love. DigitalOcean stands out from the crowd due to its simplicity, high performance, and no billing surprises. Join a community of over 3.5 million developers on DigitalOcean. Sign up with a free credit at do.co/SERadio.
Hello, this is Jeremy Jung for Software Engineering Radio. Today I'm speaking with Derek Collison. Derek is the creator of Cloud Foundry, NATS, and the current founder and CEO of Synadia. He previously worked at Tibco, Google, VMware, and Apsera. For much of his career, Derek has been involved in building messaging infrastructure for applications. I'll be speaking with Derek about different messaging patterns, how they fit modern applications, and his latest project, the open source messaging system NATS. Derek, welcome to Software Engineering Radio.
Thank you, Jeremy. Great to be here.
First, I'd like to kind of have a baseline. Could you define what a message queue is?
I could, and I will, but I think everyone's definition is probably slightly different, and it's evolved. I mean, these have existed for quite a long time. And it's the notion of if two applications are trying to communicate, and at least in the older days, a lot of times they weren't online, at the same time, they wanted to kind of package something up and say, this is what I want you to process. So when you come online, please come here, pull this thing off of this queue, and go ahead and process that. And there could be multiple ones of us, kind of like in a McDonald's line, that are pulling from the queue of new customers coming in. But I think that's kind of the basis of what the original queuing structure was. And it goes way back to computer science structures and stuff, but they started to use that pattern as a way for different processes to communicate.
And sometimes you'll hear the term message bus. Is the message bus the same thing as a message queue, or is that something built on top of a queue? How would you define a message bus?
Yeah, so in the late 80s, I think there was a different pattern that started to emerge in addition to queuing, and that was traditionally called publish subscribe. And it was specifically trying to solve problems for very specific verticals where instead of having a pattern where I was trying to tell a whole bunch of people about some set of information, let's say a stock price. And in the times before publish subscribe actually became popular, the notion of, and again, for the audience, this was on very, very slow networks compared to what we have today, even compared to, let's say, LTE on your phone. The gist of it was I would call you first, say, hey, price of IBM is this, hang up the phone, and then I would just go down the line. And it started to become obvious that the line was getting longer and longer, trading was becoming more and more popular, and that as things were starting to speed up and algorithms were starting to take place of doing trades on their own, so to speak, it was the very, very beginning of that, versus a human, that the person in the front of the line got a huge advantage over the person at the end of the line. Right. And so the gist of what was trying to be solved there is instead of going from a one-to-one communication and I keep walking down the line of everybody who's interested, we would turn that into a radio station. You would tune in to, let's say, the price of IBM. The stock ticker would say it once and everyone would get it, similar to like the old school radio podcasts like that, although these are on demand. And so what happened was you had this notion of queuing, traditional queuing that came out of, deeply rooted in computer science structures and as a communication medium, mostly dominated by IBM and MQ series, but there were others. And then there was companies starting to evolve into publish subscribe systems. And so now all of a sudden you had a queuing pattern and you had a publish subscribe pattern. When you combine those two in some form or fashion, and then we have to throw in a little bit of notion of quality of service. And the two that, there's three, but the two that most people deal with is at most once, meaning almost kind of like a fire and forget, kind of like the way your brain works. I'm going to shoot it out there, and if you catch it, great. And if you don't, well, maybe you'll get the next one. And then, of course, there is a quality of service where it's at least once, meaning I'm going to hold on to it. I might put it on disk. I'm going to wait for you to come online, again, like in more of the batch processing days. And so when you looked at queuing methodologies, queuing patterns, pub sub patterns, multiple qualities of service, including the third, which is exactly once, which is a whole other show probably on its own. Kind of putting all those together and saying, hey, we're not going to have lots of these. Jeremy's going to have his own, Derek's going to have his own. An organization or possibly even company-wide, we kind of say, no, we have one of these. And that's kind of what was determined to be like the enterprise service bus. And everyone kind of plugged into it, kind of like your nervous system, a spinal cord, so to speak. And they became very popular for a while. And they still dominate as an abstract pattern that feels like the right way to go, even in today's landscape. But I think the landscape today has changed so much that that technology has to change quite a bit. And we've seen that, I think, with entrance into what was very much a legacy-rooted technology that some installations technologies have lasted 20, 30 years, to new entrants into this, which might not sound new to the audience, but for the people who've been doing messaging for multiple decades or so, Kafka is kind of a new way to look at the problem. And I think it's got a lot of deserved attention about thinking about the problem in a different way. And so it's introducing new patterns to those pub sub, queuing, request reply, and then the qualities of service that kind of made up the technologies of the past.
I want to make sure we sort of define some of the terms you use there. You kind of went into at most once delivery. I'm assuming that means that the message will get to the subscribers at most once, but it may not get there at all. Is that correct?
Correct, yes. It's like most people call it a fire and forget model, meaning whoever's producing the data fires it off, and if you're not online or you miss it because of an interruption somehow, there will be no attempts at redelivery. And it's actually a pattern that most people skip over and go, ooh, I don't want that. I definitely want to go down the line and look at these others. But as you start looking at systems and becoming very much distributed in terms of how many moving pieces there are and looking at how you would build resiliency into these, they're actually ones that dominate the architectures that I've been using, including the one I used to build Cloud Foundry, at least the control plane for Cloud Foundry. So hopefully the audience will not just skip over that and start looking at least once or exactly once semantics, because I think there's some great use cases where it's simpler, it's more resilient, it's more predictable, and you get actually a more resilient system from the outside than you might expect.
And I think I want to come back to this since with NATS, I believe you made the decision to have at most once delivery. The other thing you had kind of talked about with a message bus versus a queue. So what makes something a message bus specifically, as you said, was the pub sub capability. So it's being able to publish a message and have multiple people receive it. Whereas the queue was people would be kind of in a line and would remove things one at a time, and only one consumer would get each item. Is that kind of the correct distinction?
Yeah, I think that's fair. Where I think I was trying to direct the audience is that there was a traditional queuing product like an IBM MQ series that dominated the landscape. And then there was pub sub technologies like TIBCO's Rendezvous, and there was others. And then all of a sudden TIBCO came out with an enterprise messaging system that had pub sub, and it had queuing, and it had request reply. And I think although TIBCO was not the only vendor in this space, I think that kind of rooted the definition of what an enterprise service bus might look like. It's combining multiple patterns, combining multiple qualities of service all into one thing. So it's one infrastructure piece, so to speak, that your application could kind of pick and choose which pattern, which quality of service made the most sense for the application itself.
So we've got the queuing, we've got pub sub, we've got request reply. Request reply is really no different than an HTTP call to a REST endpoint, that sort of thing. Is that right?
Well, yeah. In terms of a messaging pattern that's doing request reply, it is trying to dominate on the pattern of I'm going to ask you, Jeremy, a question, and you're going to tell me the answer, right? And you can look at that as RPC, request reply, is HTTP, right? HTTP is fundamentally a request reply protocol. Every time you send in a request, you're going to get a 200 or 404 or 500 or whatever back. So yes, that's exactly it. Where I think we could get into a discussion of these patterns is that I think modern systems, have different needs and wants as you transition from idea to development to production, and then going through all the other arms of production, so say regulatory, security, compliance, quality, meaning the SLAs and things, where all of a sudden that pattern, if it's the only pattern that exists, really limits the ability to allow production to kind of get their job done as well. And so we can get to this, but talking about NATS and kind of the original design concepts of NATS is to be a technology that could go from idea and multiple patterns, but then you pick one as a development methodology, but then it doesn't limit production. It doesn't limit, the quality of service of the system or monitoring or, again, regulatory or compliance or security teams. And I think that's really important in modern systems of it's not only that you start at the beginning with a basket of different patterns and qualities of service. You have to realize that as a developer, you're picking one to get your job done. But that doesn't mean that's the only job that might need to be done with those messages, right, that we're sending back and forth. I think that's a really important concept that I try to communicate with engineers that I come across and are asking, well, how would you approach this or how would you do this? And, before we officially started the call, it's definitely not an IQ thing. It's a scars on the back type of thing. But with the right technology, it's amazing how many of the friction points you can reduce so that you don't whiz through development, feel really good about yourself, and then take 6 months to actually get it deployed out into production. Those types of things.
I think a lot of developers who are just starting out, when they want to talk to applications, they're thinking more of HTTP-based calls like SOAP or REST, or they're thinking gRPC. And so all of these are very request reply oriented or RPC oriented. Can you give some examples of some common problems that can be solved by using a different messaging pattern?
Sure. So for the audience, let's make sure we're kind of on the same page. As a developer picks a request reply pattern, which, by the way, still dominates, right? I do believe apps are becoming more sensitive to doing eventing and doing telemetry data and things that might look more like PubSub or streaming, like, right, where if you're looking at Kafka as a technology. Where I think the difference comes in with something like NATS, and there's other technologies that do this as well, is that request reply is a first-class pattern. It just happens to be implemented with PubSub underneath the covers. And so what that means is that the developer says, well, yeah, I'm sending a request to Jeremy and I'm getting an answer back. That's what I have to do, right? That's what I am tasked to do as a developer or a systems engineer. And that makes total sense. And that pattern should dominate still a lot of the interactions, whether it's async or not, inside the app of, hey, I'm asking a question, I need an answer back. Where I think the difference in the approach that we've taken might come to light is you say, great, I know where Jeremy is. I send him a request. I get a response back. Everyone is happy. Now, when we move to production, it's like, okay, tell me where I can find Jeremy. All right. So there's an issue of I need to find Jeremy. And by the way, I probably am not only talking to Jeremy, I might be talking to 10 other applications. So now as I move into production, it's like, okay, I got to know where they are. Of course, production is going to say, well, Jeremy's really fast, but, John over here, he might be a little slow. So now all of a sudden we want more than one John, but we don't want Derek to change. So we're going to tell Derek not where John is, but where a load balancer is. So now there's this new process running. And I think the audience, these all will sound very familiar, right? Now all of a sudden I'm sending to a load balancer instead. It picks one of the Johns. It understands state affinity if need be. XYZ returns back. Now all of a sudden we didn't do that for you, Jeremy, but now we want to. Jeremy's becoming really popular. Now all of a sudden Derek, the app, might have to change, or at least my configuration has to change. Now somebody comes in and says, well, here's what we really want. We want to watch all requests from Derek to Jeremy. Most people say, well, that's easy. You log everything, and then you move the logs into Hadoop, and then you analyze them and all this other stuff. You add a sidecar, you add a proxy, you add this, you add that. And what you're doing is that you're asking production, I think, and production and SREs, by the way, are very good at this these days. They're like, okay, I kind of get how to do this. I know what I'm doing, X, Y, Z. Then, of course, there's the whole security demand, which is, well, how do I identify Derek? How do I identify Jeremy? Is it the developer problem or is it the production problem, systems problem? And where we looked at something like NATS is that we wanted to transition and have Derek, the app, and Jeremy, the application, the backend service, let's say, not change, not even really have to be reconfigured, and can move all the way through this. So what's happening is, and again, this is just a distinction around the big theme that I've always talked to people about, which is never assume what the message that you send today is going to be used for tomorrow. So our dominant pattern is I'm sending Jeremy a message, I get a response back, and that's totally okay. Within NATS, though, that's a PubSub, meaning that if someone wants to come on and say, hey, I want to run 3 Jeremys, you, the original Jeremy, and me, the original Derek, don't change at all. We never even stop running. So operations, there's no reboot, restart, change configuration, anything. We just start 3 more of them. So now all of a sudden there's not a load balancer, there's not something else to manage. All of a sudden it just kind of works. And all of a sudden we're doing load balancing and we can scale up and down at will, not dropping messages and all that stuff. If security comes along or quality of service comes along, meaning not a piece of technology, but a group that says, hey, we need to make sure that when Derek asks Jeremy something that whoever's fault it is, it has to be in and out, in 100 milliseconds, 200 milliseconds, right? Google had these hard and fast numbers of the request hits the front door and it's got to be going back out in, when I was there, it used to be 200 milliseconds, right? It was kind of a hard and fast rule. With a technology like NATS, a group can come along and measure that all day long. And again, you and I have never changed. We've never stopped running. We've never stopped doing anything. And so now what happens is you look and you say, hey, there's a dominant request reply pattern in development. But as we move into production, right, the fact that those requests and responses are also pub sub means we can attach any number of listeners. They can be normal. They could be their own queue. You can do request reply. You can do pub sub. You can do queuing all with the same substrate. And it doesn't kind of box you in and limit you. And especially it doesn't make production become more complex, lots of moving pieces, right? Because in dev, it's like, this was easy. It was me and Jeremy. I'd send him a question, he'd send me an answer. And then in production, you go, well, there's 8 different things running around just trying to support that one pattern to do load balancing and logging and collection of logs and security and compliance. And so what we've seen is that we've seen a complex problem become more and more complex as you move from the dev pipelines throughout. And we don't think that necessarily has to be the way it has to be.
If I can try and break it down here, often a developer will start with a request reply pattern over, say, HTTP. But if they were to move that to a message bus such as NATS, you would be able to have the discovery of the clients be a part of the message bus. So if I want to talk to a service, I don't necessarily need to know the address or the name of that service. I can send a message to NATS, and that can get routed to the correct client. As a part of NATS, you can also have load balancing. So if I have 10 instances of my service, let's say I have a service that's going to process or resize an image. When I make the request to have this image I send resized, NATS can actually handle the load balancing and pick a service to talk to for me, rather than me introducing something like, say, Nginx or HA proxy to choose the service to talk to.
Correct.
And then you also mentioned that it is a request reply pattern, but internally it's actually using publish and subscribe. So you're publishing a message into this message bus so that other services that are not necessarily the target or the ones that would be performing the work, they can listen in and log out the results without changing the software that's talking to one another. Did I break that down correctly?
No, that's exactly right. And from doing it so long, I skip some pieces sometimes, specifically about, I'm not tying Jeremy per se with a messaging system to a host name or an IP or the IP of a load balancer, whatever that is.
Mm-hmm.
And I think there's still a tremendous amount of value in that. Where I think the value has even become more obvious is that it's not only I tie, addressing and discovery to DNS or IPs or whatever like that. We're also now tying identity, right? And that's what people naturally think of as identity. But I think it's really time for the groups at large that are really kind of pushing the envelope and innovating around distributed systems, microservices, whatever you might want to call them, that we might want to take a step back and say, hey, is that really the right way we want to go? Do we really want to have communications tied to, IPs and identities and security and auth-Z and auth-N models tied to IPs? And I think most people say no, but we still kind of do it that way, even though our vision, I think, collectively of the world is that, computers and servers and, resources like memory and network and stuff like that are becoming very ephemeral, very fungible. And if we're thinking about how we want to design a system, we want to be able to just use whatever we want to use and be able to carry along our identity and the security constructs. And of course, how the communication fabric can work, has to be the same, but it doesn't matter which machine I'm running on. And again, I've been doing this a long time, so I do remember the day where I could walk in almost any data center for at the time our customer set, and I could walk down the right hallway or right aisle, but between the servers, stop, look down, and go, our stuff's running right there. And I actually still even know the IP, what it's supposed to be. We don't live in that world anymore, but we really haven't unshackled ourselves from. That's still kind of a main way we use or apply security of communications and identity. And I think it's a good time for us to kind of take a step back as an industry and say, I don't think that's what we want. And we're kind of in a transition period now where we're starting to move away from it, but we've still got that one kind of link that's kind of holding us down.
If you take a look at more of a traditional design of an application, you might have a load balancer, and that load balancer needs to be aware of the IPs of all of the services that can field that request. And you're sort of saying like, maybe that's not the right place or the right abstraction. Maybe this messaging bus should take care of who you can communicate with rather than having sort of these extra pieces you bolt on in order to provide things like service discovery or basically just finding clients. Maybe we're not building the functionality in the right place. Is that your opinion?
So what I think we need is this communication infrastructures like these cell towers, that they're just ubiquitous. They're all around you, and yet they carry amongst them, as soon as you hook up to one, you're allowed to have an identity and allowed to have these messaging patterns that you have. And the messaging patterns follow you around. The identity follows you around. The identity might not be just one thing, right? It might be this application running on this hardware representing Jeremy. And that has security and identity and authorization primitives that can move freely. And they're not centralized. It's totally decentralized. Very, very, distributed, but ubiquitous. And I think in the old days, people go, "Oh, message bus, we got to run one big thing or maybe two big things in active, passive, or active, hot mode type stuff." And I think my hope for the audience is to not think of it that way. To think of it as a always on, ubiquitous, kind of like the cell tower signal that you can just use, and all of the things that you care about are taken care of you without having to deal with or really interact with, from a perspective of identity, security, authorization type stuff, with this communications provider, right? We don't necessarily worry about the cell tower having to be aware of our credentials to log into Gmail, let's say, right? Gmail handles that, and we interact with Google to figure what that looks like and what that means. And so I think there's a really interesting opportunity to think of things that way. So not the old message bus, not by any stretch, but this notion that these things are everywhere. Matter of fact, I could be sitting here and typing something, and it says, "Oh, I found one right in your house." Right? It's baked into your router for Comcast or Xfinity or Spectrum or Charter or what do you have, at least in the United States. And it just works, right? It found it. It has a link to it. It's secure by default. And all the semantics of the app that was working when I was at the office, I was in the data center, I was in my car, it's doing the exact same thing here, but its point of entry is actually in the house. So if I'm actually talking to something in the house, it actually never leaves the house, right? It doesn't trombone all the way to the cloud and come all the way back. And I think that's a powerful way to look at it if the technology supports a lot of those things, if that makes sense.
Yeah, it sounds like traditional messaging buses are centered around a small set of powerful servers, so you could get a situation where you want to talk to a service that's located in the same building as you, but you have to send a request all the way to this server and then it has to come all the way back to your building. But looking to the future, a NATS instance is a single Go binary, so you got limited resource requirements. So you can have these instances running all over the place, maybe in your office or your home. So you send a request to your local node and that could get routed to the service in your own building rather than going through this long path. We've been discussing about how I can talk to Derek's service without knowing anything about Derek. Like I don't need to know your IP, I don't need to know your host name, that sort of thing. And the primitive that's used in messaging systems tends to be a subject or a topic. Could you kind of go into what that is and how that's used to find services?
Traditionally, people have either topics or subjects. They're usually comprised of multiple tokens with some sort of separator. Either it's a slash, or I always use a dot just because that's what I've always used historically. So it'd be something like foo/bar, right? Or Jeremy slash, request one, request two, whatever those are. And many systems allow you to express interest in things and group them with wildcards. And wildcards just kind of mean, it's kind of like a regex, if a very simplistic regex, where you say, oh, well, I'm interested in everything Jeremy's doing, so I want to listen to Jeremy/stars, or Jeremy.stars is what we always use. Doesn't usually matter. And so most systems use that as our addressing space. So we can clump a whole bunch of things together with wildcards. And an example around that might make sense for the audience is if I have Jeremy.some action, I don't know, create dot, customer ID is kind of a subject that's being thrown around either as an event or whatever. And I say, I want to watch all new creations of customers, right? And so I don't want to have to say, I want to subscribe to Jeremy.newcustomer. Whatever that customer ID is. I don't know what that is, but I could say .star, right? And so then I actually get the real subject, let's say customer number 22. I can see that, but my subscription was just one. And subscriptions, by the way, I think a lot of the audience probably knows this, but they form that interest graph, which is extremely dynamic and something I've been working on for over 20 years now, and I still don't necessarily have it where I like it. But to be able to optimize that interest graph and how you actually propagate that, such that when someone sends to it, they know that has to get to me, is kind of almost an art form. Everyone thinks it's a weekend project, and I can promise you it's not. But that's the general gist, right? There's these topics. They're made up of multiple tokens. Most people put them in hierarchies. Most companies that decide, hey, we're kind of going all in on this, and we really care about this, and we, whether it's an old school enterprise service bus or maybe something newer, they usually spend quite a bit of time trying to map out what that topic hierarchy or that subject hierarchy looks like so that we don't step on each other's toes 2 years down the line. And so it's a very large design process on how to try to set these up. And it in itself is an art form that I've seen lots of people do and engage in, and some are better than others, but it always was kind of a pain point to saying we want this, this technology that we can communicate with all of these backend services for our org, but there's this exercise that we can't skip. We got to kind of think up front so that Jeremy doesn't accidentally pick a subject that Derek was using or a topic that Derek was using, and all of a sudden we're stepping on each other's toes.
And this sounds very similar to the problems that developers face when they're building, say, a REST API, where they have to decide what are my, endpoints going to be, what are the functions you're going to be able to call, how to name your subjects or your topics. Sounds like the same kind of problem, the same kind of art.
It is. And so what they do is exactly, you're exactly right. Meaning they'll pick, I call it the bottom part of the tree, what the nouns and verbs and how you want to put those together. And then as you move from dev to test to production, that kind of prefix changes, and you can envision that as I have a totally different, host URL for my REST service, or it's the same host URL, but I have a /Jeremy and Derek has /Derek. And then we both have all the same verbs potentially underneath. The same exercise happens in messaging systems with topic design or high-level subject design.
Digitalocean is the easiest cloud platform to deploy, manage, and scale applications of any size, removing infrastructure friction and providing predictability so developers and their teams can develop faster and focus on building software that customers love. With thousands of in-depth tutorials and an active community, we provide the support you need. DigitalOcean stands out of the crowd due to its simplicity, high performance, and no billing surprises. Try DigitalOcean for free at do.co/SERadio.
What are some common mistakes you see people make when they're trying to design their topics?
It's either one of two things. One is they don't think hard enough about it, and they step on each other very early on in the cycle, or they think so hard about it that they've made something that's so brittle that is resistant to better ideas coming in down the line, right? Say, wait a minute, if we had actually kind of constructed the subject hierarchy this way, right, we could have used certain pieces of information from the subject, being able to separate those message traffic patterns out. But now we can't do it because we're locked in, and everyone says you can't change, any of this. So it's usually one or the other. They don't think hard enough about it, or they think too hard about it. But again, I think there's opportunities where the way people think about these problems can radically change.
There's a messaging standard called AMQP that systems like ActiveMQ and RabbitMQ use to send messages to one another, but I noticed that the more recent systems such as NATS, Google Cloud PubSub, and Amazon Simple Notification Service all don't support this. Why do you believe that is?
Sure, and I can't obviously speak for any of the cloud providers. I can give an opinion not on how they implemented their tech. In terms of the protocols, we could have a whole show on protocols. I was very aware and understood why AMQP became. It was not in any small part an actual reaction to TIBCO, right? And their pricing model, which was beyond my control at the time. But machines are so fast these days, and networks are so fast. All of the massive amounts of bending over backwards trying to squeeze everything out with binary protocols doesn't buy you much. And what it does is it constrains your ecosystem, very much like Redis. And Salvatore is a good friend of mine, and I really have always been a huge fan of his and what he's done almost single-handedly, with Redis. And so when him and I worked at VMware together, I said, Redis is a text-based protocol. And he goes, yeah. He goes, I can make it a binary. It won't make a difference. Now, Redis is all request reply, or most of it's request reply. You can pipeline and do things to speed stuff up. But for NATS, when I went and said, I want to build something just for me, it's not going to bend over backwards. It's not going to have all these features. It's going to protect itself at all costs. I just run a server, and 90% of the time, that's all I have to do. No config. It just figures stuff out. This was almost 10 years ago. And it just does, everything is pub sub, and I can layer on request reply and queuing, and I'm done. And what I did was I just didn't have a lot of time, believe it or not, to build this thing for Cloud Foundry. So the very first thing I did was a protocol parser that was actually just regexes in Ruby, believe it or not. But it could do 150,000 messages a second, which at the time was pretty cool. Now, of course, the NAT server has been written in Go since 0.52 of the Go language. A modern iMac now can do probably upwards of 80 million messages a second with NATs. And we've never changed the text protocol. So doesn't matter. The protocol design is an art form, and I still love it at one level. But what we did with NATS is that because the protocol is not only text-based, but it's extremely simple. There's only a handful of verbs that you need to know to build your own client. And so our ecosystem now is not constrained by the only way a client can be born is if somebody from the core team decides to build one. We have an amazing ecosystem of clients that we never wrote a single line of code for that people can do. And I think it's based on that simplicity and the fact that it's text-based can get them started very quickly, if that makes sense.
When architecting an application, you often have a lot of moving parts. You were talking about services communicating via HTTP, and we recently did a show on load balancing with HA proxy, as well as one on service meshes with Istio, which uses Envoy for its service proxy functionality. It sounds like what you're saying is because these pieces can be complex and may require a lot of ops work to keep running, it might actually make more sense to, rather than use all these different pieces, to use a messaging system like NATS, which can handle the routing, the service discovery, the load balancing, and be designed in such a way that the ops overhead is very low. Is that sort of what you have in mind?
Yeah, and exactly. And the only thing I would add on to that, and again, this is kind of that aha moment that we had, is when we designed the secure multi-tenancy. Right. Think of that as like a container for communications, messaging communications for digital system service devices. When we designed it, it was to power a global utility, to power a single URL that everyone could tap into and use and feel like they're isolated. It's their own container, their own sandbox. Meaning, Jeremy, you get a sandbox, right? And every message you send, regardless of how you address it, topic, subject, whatever that is, only the people that are also in your container, your namespace, whatever you want to call that. We call them accounts, can see any of those messages. And again, earlier in the talk, I talked about, but I want to promote sharing, where the massive opportunities and power of the World Wide Web and the internet and the global cellular network have really rooted on is that if we wanted to talk, we didn't have to do anything besides start talking, right? We were already kind of connected. And so we did that, and we designed this notion of saying, well, you have your own little sandbox and you communicate in there. And you control everything in that sandbox. And you can import things into that sandbox. So I could import, Derek, and he has a service, and I can send a request to it, and he sends me, what's 1 + 1, and I'll send you 2 back. Very simplistic, but for the sake of the conversation. And you've imported that into your sandbox, and you put it anywhere you want it to, meaning you control that. So now, if the audience remembers back to the, big grand design of subject spaces and topic spaces, and people either did too little or too much, now all of a sudden there is no design stuff. You can actually say, okay, I have internally in my little sandbox for Jeremy, I have this one subject and I have this other subject, and then I'm importing Derek, and it's on /Derek request. And you define that. It does not matter what you call it. It's your world, right? And that's how you import things. Now, eventually you kind of go, ooh, I finished. I want to put my service or this stream out to the world. So I'm going to now export it, right? So I'm exporting this thing, and you might need permission, and that's okay. You'll figure out how to get permission from me. But now all of a sudden what we've realized is that people who were designing these systems, and again, they went through a pattern. We want to innovate. We want a new tech. We don't want the old stuff. Let's pick something new. Let's do POCs. Let's try not to be a silo. Let's set up a big service. Wow, that really didn't turn out the way we wanted to. Crap, let's go back to these silos. When they look at something like NATS, which again exists today now with these technologies, they go, I just click a button and you have your sandbox in less than 2 milliseconds, because I don't care what you do on it. And if you want to start importing stuff, let's say from Derek, that's between you and Derek. I don't care. As a company, organization, dev, test, prod even, it really doesn't matter. As soon as Jeremy goes, okay, I'm ready to export, we've had multiple users and customers now go, this is perfect because that is your defined interface. That's your microservice. That's exactly what that is. It's how I would import it, how I would send a request, what the response looks like. All of that's kind of captured in that very simple primitive of, and I wish I was smarter than our design, was just to make sure that they're isolated by default. Everyone's like, that's perfect. I don't have to design subject spaces because I can export it as /Jeremy1, and Derek can import it as /Jeremy's cool service /request 45 or whatever. Or stream. You might be a really cool stream that I want to import from you, like events and data and streaming data type stuff. And the cool thing is that when you get to that point and we're watching customers go, this is great. Every little business function, microservice or whatever, they get their own little sandbox. They import whatever they need to get their job done. And then once they're ready to export their own version of our cool stream or service, they do an export. There's an audit real quick from security and stuff. And what happened in so many of these customers already is the security team comes in and they usually have a look on their face like, this isn't going to go well for you. And they look at the tech and they go, they actually thought really hard about secure by default. No private keys or passwords are ever given to the system whatsoever. We anonymize requests. So I know I got a request from someone who's authorized, but I have no clue who it was from. Those types of things keep reducing that friction point that I was talking about, not only from a dev perspective, but ops and security and regulatory and things like that. And again, I wish I was smart enough to know that this was coming, but it's essentially defining the way communications work in this new world where there's service meshes and microservices, but in a very different, simple, secure by default way. Hopefully that makes sense.
I want to make sure I understand the way that you're using subjects or topics in this design. You were describing how you would have a subject and it could be Derek /image service /2 or something like that. And you said that you have sort of your private, I don't know if you would call it a namespace, but you have like the names that your system understands, but somebody who wants to talk to that service, they would be able to import that subject or that topic with a different name. I was kind of trying to follow how exactly that worked.
No, that's exactly right. Meaning when we give you that sandbox of communications, you control everything that's in that sandbox, not just the stuff you're designing, but the things you import. And so let's say I have, image processor.request, whatever that is. And I just call it ip.req. I like little short things. So that's all I call it. And I'm running. And I want to go into production. I say, I'm going to export this thing. Production says, okay, we don't care where you are running this, because when Jeremy comes along and says, hey, show me the list of stuff that's available. Oh, Derek has this cool service called whatever, but it has a description and it has, open API link that shows that it's the request looks like this, the response looks like this, and you go, great, I'm going to import this. He needs permission. He's going to give me a token that allows me to do it. But when you import it, you put it wherever you want. So you could pick whatever subject you want inside of your sandbox, and you send a request to that subject, and I magically get it on mine. But it's totally secure. It's always buttoned down. It's always auditable. It's always, all these things. And then, of course, I get it. I see it. And you sent the reply subject to me. But this reply subject isn't the one you sent, and it's totally anonymous to me. I have no clue what it is. But when I send the message, the response to that, you get the answer. And so now these groups, again, whether it's a serverless or a microservice or just an org, they control everything in their sandbox. So now all of a sudden, instead of having that 4-day-long topic/subject design session, it's like we can sit around at lunch and figure out and make these very, very short. We don't have to have like I'm not picking on Java, but like a Java variable name that's camel case and has eight humps, and it takes up 40 characters or whatever. And so now all of a sudden it's extremely simple. And what's interesting as an observer looking at you and I, they can easily say, oh, Derek depends on these 3 things because those are what he imports. And Jeremy depends on Derek because he's importing his service. And Jeremy can run anywhere he wants, as many of them as he wants. Derek can run anywhere he wants, as many as he wants. But it's locked down, meaning we know that someone who's sending the request is authorized by the Jeremy Sandbox, the account that has users that have their own permissions. So you might have users that can send to the service and others that can't. So all of this stuff just kind of works together, and it's easy. And it's by default. It's not like you have to go into ops and say, well, how long is it going to take you to bolt this stuff on and make it secure and understand TLS or whatever that construct is, and then prod has to do all this other stuff. It's, no, my development from day one, the very first message I sent was already secured. We haven't got there yet, but we also believe that if we could say a user of the system says, I actually want to treat this system like a zero trust system. I don't want to trust it at all. Of course, it might not route my message where I want, but also, no matter what I'm sending it, it cannot compromise me or understand anything about what I'm doing. And we're not there yet, but we're closer than people might think. And so then if you combine these accounts in your own little sandbox, you manage everything inside there, so it makes it very easy. And then there's these things, exports and imports, to define how we talk between those interfaces, let's say, right? And then you look at this notion of, and I can use a global utility. Any cloud provider just works. Same URL will pin you to the AWS East region because that's where you're running. And if I want, I can run a server that has a little server, a NATS server, same as the other ones. But again, you start up, it starts up instantly, no config, or extremely low config. And it can transparently join this global network in a way that it's zero trust. So I can be talking to my own little server in my data center, but then I got to reach across to, let's say, Europe and talk to Jeremy. It just all works. It's all secure. It's all auditable. It can even run in zero trust mode. That, I think, makes people think a lot differently about how they might solve the problem. The problems aren't necessarily different, right? We're still trying to decompose software systems, make lots of little pieces, but we just don't want the lots of little pieces to be painful, to stand up, to develop, to operate and maintain, right? But if it's easy to do that, it makes sense, right? Do lots of little pieces, and of course there is a systems engineering component where you're like, we should combine these for mostly latency reasons, right? We want the experience is that you get it in 10 milliseconds, not 180, because it's 5 microservices talking over HTTP through load balancers, ping-ponging back and forth, right? And I think eventually you have to pay the piper, and I think a lot of these microservice, service mesh technologies where the complexity is just so high, eventually people are going to say, hey, is there something simpler, that we can potentially use? And we hope we might be a part of that story.
Hoping that making the communication be this solved problem, the security, multi-tenancy, the sharing, have that be handled, and that way you can think differently about how you design your services, where you don't have to worry about the complexity of adding an additional service, and you're kind of talking about the latency that might come in as you bring in the load balancer and go through HTTP and all these different pieces. How this may hopefully encourage you to design your applications differently.
Yeah, and to be quite frank with you and the audience, when we were looking at where are the potential business models for something like NATS, one is, we could run it as a service, but that was a massive failure, and the reason it was a massive failure is if you are truly treating it as a silo technology just for you, running NATS is usually you click a button or run a Docker image, and we have a lot of users who really love the technology and love how responsive we are, but they're not going to pay for us to run it because they just run it. They don't even monitor it. One of our customers said, well, we have these major events every 2 years, and that's when we decide if we want to upgrade or not. And I said, so you don't even monitor it? You don't even, and they go, nope, it just sits there. It just works. We like that. But for us, that presented a massive thought exercise challenge around, well, they don't want to pay for support because it's so easy, and they don't want to pay us to run it as a singleton. Is there any opportunity around software that's just easy to generate a business around? But I wouldn't go back on that. In other words, I wouldn't go back and try to make it more complex and buggier so that you're going to pay me. And so, the team that kind of maintains it, we're not a large team, but we have a lot of people who have been doing this stuff for a long time, and they take an incredible amount of pride in the fact that it just works, and it's really easy both to start. I put up a demo server about 4 years ago, and it still runs, and we see people use it all the time. So our getting started thing is take a client, which are very small, Node. I think we do 34 languages now, something like that. And if you want, just point to the demo server and knock yourself out. And they go, okay, well, what if I want to run my own server? It's like, well, just now Docker is so ubiquitous from a development, on most people's machines. It's like, well, we have a Docker image, so you can just kind of go Docker run this, and they go, perfect. And then we never hear from them again. Or we hear from them far in between, like months, and they go, okay, now I want to run a small cluster. It's like, okay, here's, the Docker command, or here's the NATS operator, or here's how you might do it, And again, they go, wow, this is so easy. And we're like, good, that's what we want, but we also think that's what we want to see in stuff that we use too. It's not only easy to get started, it's easy at the end of the day running something in production, and that's not always a trivial thing to try to hit on all of those cylinders, and we are by far from perfect, and there's a lot of other great tech out there that does it better than us, but we think the trends are going to be moving towards, I want to think about the problem in the same way, but give me the tools and technologies that are vastly simpler. They don't make my life more complex and add more complexity.
If somebody was building an application, and the example I want to use, because I believe you did a lot of work with financial systems at TIBCO. Let's say I had a trading system and I wanted to receive live prices. So like my clients are kind of getting the updates of the different stock tickers. And I want to be able to store a history of, all the prices of all these stocks. And I want clients to be able to buy or sell, and they need to be able to not have like duplicate operations or lost orders. So I kind of wanted to see, like, how would you build a system around that, given the sort of features that NATS has and the features that it doesn't have? Like, for example, how you've described how NATS has exactly once delivery, or sorry, not exactly once, at most once delivery. So there's no guarantee that like my order would get to, the exchange, things like that. So if you could maybe kind of walk through that.
Sure. And just as of note, in the early, mid, late 90s, those systems cost tens of millions of dollars. So we'll try to walk through that. But yeah, you've essentially just defined a full-on trading desk, and developing software for that was paid very handsomely I still think to this day. So there would be the notion of, there's a stream now. We call them, by the way, NATS as a project includes both at most once and at least once. I call it STAN. Most people know it as NATS streaming, which does give you at least once. But the way we would do the stock quote part would be, we are just sending out, on, let's say, NYSE dot whatever the ticker symbol is, and NASDAQ dot ticker symbol. And we have our own account that we talked about before, and we export those two. and you can import them, but you need an authorization token for us. And that's all handled and easy. Just make sure that I will authorize Jeremy to receive the NASDAQ ticker. So myself, because of the way networks are and they're fairly efficient, is I would not make it anything but at most ones. It's fire and forget. If you miss it, you probably want the newest one when you come back online, not spend 10 seconds going through all the old ones. I think that's an anti-pattern.
So that would be fire and forget to all of the clients.
Yeah.
Okay.
Yeah, because again, semantically, do you want me to give you every update, or you want to know at this point in time I'm connected, I have a green dot, meaning I'm good, and I know that Google's price is this or Tesla's price is this. But I would put it in its own account. That means, Jeremy, as you're importing it, you have to get permission. So we know there's that security piece there that you are allowed to do it. By the way, these security things are JWTs, ED25519 keys, have expirations. They have all these things that people want from a security and production side. And you as the developer don't have to think about that. Just it all is there, just works. So now you can import it, knock yourself out. Now let's say you, Jeremy, also want to save all of this stuff. And you want to have your own kind of historical stuff because you might want to start looking through it and analyzing it, maybe putting some machine learning on it, maybe trying to start a hedge fund. So what I would say there is once that stream actually enters into your sandbox, your account, that you will have your own NAT streaming system, which you can think of it like Kafka, right? It just stores a serialized log of messages, and then you would store them that way, and you can retrieve them through Stan2. Say, I want to create a new application. I want to start from the beginning of time, or I want to start an hour ago, or I only want to see Tesla stock or Google stock. And you can do all of that by running this service inside of your account for the ones that you're saving. For the trading desk, meaning you want to do a trade, let's say. Again, there's some interesting ways to approach the problem. But in general, you want to import a service that if you send a request to, you get an answer back saying, gotcha, you're good, right? I sold your Tesla shares, or I sold your Google shares, or bought Apple for you, or whatever those things are. And again, just knowing that these things cost tens and even more sometimes millions of dollars in the path to design. Today, if I was using that to do that, again, most people say, aha, now I know you're going to have to use at least one semantics here. And I'd say, actually, I don't. I'm sending a request reply. Right, Jeremy, you're sending a request to me saying, please sell this and let me know if you're good to go. Now, I could do something where I put it in a database or I mark it somewhere else because the trade settlement and the execution happens asynchronously, right? Meaning I'll tell you, okay, I got your order, and then I'll ping you back later when it's actually finalized. And it used to be T3, T+3, but now it's T+1, I think, or maybe even less, meaning the official settlement takes a day and you'll get an email or whatever. But again, I probably wouldn't use something like a Kafka or even NAT streaming to send that request because you want an answer back and you're online, right? You're there. And adding some of that sometimes is an anti-pattern, especially if you're always doing request reply. And you can think of this as, people kind of look at me, and I've had people, and this is their earnest, honest opinion. They're like, Derek, you just don't know what you're talking about. But I've kind of done this for a long time. And I always say, look at the web. If you click on, please deposit $100 into my Wells Fargo account, and all of a sudden the page goes blank, what do? And I say, what you don't do is you don't walk away. Mm-hmm. Right? You go, right. Reload, then you might check your balance, see if it had appeared. If it didn't appear, you do it again, right? And so I believe in those types of patterns. Surface that stuff. Law of leaky abstraction and things like that. Some of the worst system outages I've ever seen in my career, believe it or not, are from a message being redelivered because you told the system, hold on to this and make sure Derek gets it. But Derek, meaning me, it had no semantic meaning outside of, let's say, 5 minutes. But you delivered it to me an hour later, and I just puked.
Right.
The whole system cascaded down type of deal. And so a lot of times those things, you think it's like, I absolutely need this. I absolutely need, not only at least once, I need exactly once. I need distributed transactions. And what we've seen with modern systems is they're going away from that complexity. Because a lot of times when something goes wrong, you still don't know necessarily what to do. You only know that if it says it's good, everything was good, and you're usually very, very slow. You can't handle a lot of those things at all. We had a customer who was trying to project out 5 years in terms of load, and they wanted exactly once messaging and distributed transactions. So the messages, what that means is the messages are coordinated with another resource like a database through a formal protocol, usually XA. And we did it, and we implemented it, and I looked at the person, I said, I promise you'll ask me to come back and not use this, in a short period of time. And they did. And we came back and we said we would do a model where we would use at least once, meaning we're going to try to deliver this thing, short TTLs, the ability to dedupe, and then compensating transactions. No XA type stuff, but we can compensate, meaning if we got the message and we tried to do the database, but that failed, we'd know how to kind of unroll that, right? Anyway, long story short, that system now has been running 23 years. And so it was a lot simpler. It wasn't what they thought they wanted, but they said it was one of the best investments they ever made because of the longevity they got out of the system. Now, of course, they tweaked it and upgraded it and made more machines, more powerful machines, of course. But for something to run that long, that's I like that. That gives me a great amount of satisfaction as a technology person. But again, all of the things that the customer thought they needed to solve the problem really turned out not to be. And so that's how I do that. So we've got the stream, but it's not a stream. It's a fire and forget into Jeremy for the stock quotes, but it's authorized. So so you can audit and say, I know exactly who's allowed to watch the NASDAQ ticker symbol, right? Mm-hmm. And who's not. That means I can charge them for it, or I can internally bill them for it. You on your own, regardless of what I'm doing, can keep a stream of all of those, process them at will any way you want. And then, of course, doing the trades themselves. I would not say, put this in a messaging system, and it's the one that guarantees that the order gets processed. It's, you send me a request, I stamp it in whatever, a database or whatever. I don't believe in putting everything into like a message stream. That's not my go-to architecture. But I mean, databases have been around long. They work. They're good. So whack in the database. But once that's done, then I send you an okay going, hey, you're good to go. I have your order. And that might take, tens of milliseconds, hundreds of milliseconds, hopefully, if it's a well-designed backend. But on the messaging front, because you were doing request reply, I don't need anything except at both once. And so use something like, the global utility or whatever that is secure, and you can do it as zero trust. I'm just asking the messaging system to give me identity and securely, deliver a message to the trading desk, wherever that is, and it can keep changing and it doesn't matter. And you can keep moving, right? You got your laptop in Europe, now you're back in North America. And so that's very quick nutshell of how I would approach that today. And what I think the audience will be surprised at is that I didn't say, at least once and exactly once very many times. I did the thing, if you want to save them all for yourself and replay them, then I need some sort of persistence level and the ability to kind of get those things back. But beyond that, you wouldn't need it, in my opinion.
To sort of break it down in terms of the messaging patterns used to receive the live prices, you would use the at most once delivery of PubSub because you can send it to, hundreds, thousands of clients, millions, millions. And if they miss some, it's okay because they probably just want to see whatever's the last one. So if they drop 10 of them in between, it's fine.
Well, it's not only just fine, it's actually better. And again, you have to think, what do I actually want to see if I know? So I want to see if I think I'm connected, obviously. And if I'm connected, I better see what the exact price is now, not what it was 5 minutes ago.
Right. And to have the history of the prices of these stocks, you would make use of NATS streaming. And we had a show on streaming architecture before, and we've also had a show on Kafka before. And basically, all of these messages of the different prices, they would be stored within NATS. And if a client at a later point decided they wanted to get a graph of the history, they could replay the messages that are stored in the stream to get the history. And then finally, for the buying and the selling orders, they could use the request reply functionality of NATS. And because it's at most once delivery, if a client sends the request and they don't get a response back, then the client can assume that their order was not processed, and the application can have the responsibility of making the request again, rather than having that sort of be handled by the messaging system itself.
Almost correct. If you don't get anything back, you don't really know what happened.
Okay.
If you get something back, you either know it succeeded or it failed. But again, I think the application, and again, I would ask the audience to put themselves in front of their browser doing online banking. What are the patterns that you're doing, right? So if you get the I click on it and I got an error back from Wells Fargo, you know what that means. If you click and you say it's deposited, you also know what that means. If the page just goes blank, you have to deal with that. What do you do, right? And that's what I think should be managed inside of applications, because again, you're just removing yourself. So what happens if the messaging system blows up or doesn't respond to you? It's the same thing. You have to do the same exact error handling, failure scenario handling, as if you just sent it all the way to the trading desk. Now, of course, if the trading desk isn't online and it's the middle of the night, let's say, and it's old school, you might use something like NATS streaming or Kafka to say, no, save this and deliver it to them when they come online. But in today's world, that is the exception these days. I mean, everything's online all the time. And I'm talking directly to them, even if it's not trading hours. They will say, got it, put it in the database, you're good.
Right.
Hopefully that makes sense to the audience. So we've moved to more of an online, real time, but there is the need for these higher qualities of service and saving things and maybe replaying them for analysis or machine learning or data lakes or business analytics, Hadoop type stuff. I do believe those exist for sure, but I usually see them as kind of a, hey, let's plug this thing in and not affect anything that's going on and start taking advantage of this, not making it, I'm just trying to send a request to Jeremy. Why are you making me use all this crazy complex stuff? It's slow. I can send 40 messages a second or whatever, and the latency is really bad. And, so it almost becomes an anti-pattern if you start there. But you should also pick a technology that allows you to grow and add these things on without ever changing or perturbing what already exists.
My last question would be related to the streaming functionality of NATS. There's a lot of listeners who I'm sure are familiar with Kafka to be used as an event store. What kind of niche does NATS fill in comparison to Kafka? Is it the simpler deployment, or are there things that are in Kafka that are not in NATS? Like, how would someone make that decision?
Yeah, so we're seeing a tremendous uptake, believe it or not, where there is a need for something like streaming, but they want something that's very easy to set up, develop against, and run in production. And so we've seen quite a few opportunities where there is a large presence of Kafka, but they want an additional technology that might be a little bit lighter weight, but is still as performant and still as fast and still can store as much data type stuff. And so we've seen a tremendous amount of inbound interest that way. We don't have the ecosystem that Kafka does. We don't have all of the connectors to all the different subsystems. And we don't have the things that companies like Confluent do, where they have like KSQL. But for me, if you're trying to do something like SQL, then that exists. Stick it in a database, and you've got SQL. You've got real SQL. You don't need something that's built on top of something else. So we've seen a lot of conversations, meaning Kafka and NATS streaming and NATS as kind of a supplementary or additional technology. And so to that end, we've actually started, and we've been doing this now for about 6 months, designing kind of the successor to streaming. But it's still philosophically going to hold on to those. How do we even make it simpler from a development standpoint, but have the multiple patterns, make it closer to NATS core, but it is secure by default. It does understand all the NATS 2.0 stuff like accounts and sandboxes and sharing and all that other stuff. And so we're really excited about that and where that's going. But we believe operational ease, maintenance, scaling, secure by default, multi-tenancy, secure multi-tenancy by default, multiple message patterns, multiple QoSs, but in extremely simple, don't need to read much. We are not like this, but this is our goal, which was the early days when Jobs returned to Apple, and there was no manuals to a lot of the stuff he did. You would open it up and it would be like step 1, open the box, step 2, take it out, step 3, turn it on, you're done. No one can do that as well as they did per se, but that's kind of our goal, which is how do we make this drop dead easy from day one development through production, through all of the other things that compromise production. And we think there's a massive market for that, to combine that with larger maybe technologies like Kafka and then Hadoop and then the new machine learning and serverless and all these other things. And we especially think for serverless and being able to say this thing can be running anywhere. We want to run in an instant, but we also still want security and all these other things. Again, most people are saying we're trying to figure out how to spin this thing up as fast as possible, but you're still connecting to it through HTTP. And we do have a bunch of serverless function technologies out there that we work with, that they are using NATS and NATS streaming to power those. And they're starting to see a good amount of uptake. And again, it's not as much something that we, the NATS team, are doing per se. I think it's the market in general going, hey, we want to look at these things because they're different, make us think differently, and we're innovating. But we also want something that's just simple and just works. And so we're starting to see a lot of people keep saying that we came to you because we just need something that is simple and works. And so that's what we're going to keep pushing for.
I want to close out and ask you, are there any questions you think I should have asked or something you would just like to say to our audience?
No, I think they were all great. I really appreciate the time. I know we've gone long, but this pattern is very common, meaning I've done a lot of these with customers, and they go, we'll allocate about 2 hours. The most extreme case was it went for a day and a half. It's an amazing topic to explore and to see how we've moved, not just us as a technology, but just in general, and to talk about where we think things are going and how we can meet and drive some of those innovations, but to get something that's, a common communication thing. It's secure by default. It's not a lot of, pain to get it to be secure, right? It has these notions of these containers and sandboxes, but also promote sharing in a secure way. And, a lot of people have really, the light bulb goes off very fast for them, faster than I've seen before. I've had technologies before where I would be talking for years to customers trying to say, no, this is a better way maybe to look at this problem. And what I think I'm seeing here is that the market's figuring that out for themselves. And it makes my job trying to say what we've done about it or what we think about things and where they're going a lot easier. And it's been really exciting for me, but I've been doing this for quite a long time. But seeing the customers kind of go, oh, wait a minute, we could think of it, like this. Again, having their own Tesla moment is really exciting for not only us and being the NATS core team, but the whole ecosystem and just technology in general. It's really exciting to be able to see all of the changes that are going on and realize that the next 10 years will probably eclipse the last 50, right, in terms of progress across the board. And we just want to be a teeny little piece of that if possible.
Yeah, I think, as a developer, there's so many things for people to learn. And if we could at least cut down on some of it, from the ops perspective, from the development perspective, I think that's a win for everyone. So that's exciting. How can people follow you on the internet?
So Twitter, Derek Collison, DerekCollison. Derek at nats.io if you want to send me an email. Nats.io will get you to our Slack channels and Google groups. And I think we have about 1,500 people on Slack or so. So we're vastly not known, but the people who do know us are very passionate like we are about the tech and how you apply it. So come join us, ask us questions, send me an email if you want directly, tell me what I'm wrong about. No problems whatsoever. And again, thank you, Jeremy. I really appreciate the time.
Yeah, this has been a fantastic discussion. Thank you so much for coming on the show, Derek. This is Jeremy Jung for Software Engineering Radio. Thank you for listening.
Digitalocean is the easiest cloud platform to deploy, manage, and scale applications of any size, removing infrastructure friction and providing predictability so developers and their teams can deploy faster and focus on building software that customers love. Digitalocean stands out from the crowd due to its simplicity, high performance, and no billing surprises. Join a community of over 3.5 million developers on DigitalOcean. Sign up with a free credit at do.co/SERadio. Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.